Okay, so sine of x is negative 2/3. This is number 13 in section, it's what? It's 3.5, the harder ones, right? There was 3.5, the easier, and there was 3.5, the harder. This is 3.5, the harder. Okay, so negative 2/3 is not one of our memorized values, is it? It's not, like if you go to the unit circle, here, I'll go to the unit circle real quick. We're not going to find it there. I mean, you probably already know. It's kind of a silly exercise. But I'll do it nonetheless. There it is. So you're not going to find negative 2/3, right? All we find on the unit circle is either 1 or 0, square root of 3 over 2, a half, or square root of 2 over 2. Right? That's the only values on the unit circle. Right? Small, medium, and large, right? We've got the small, a half, medium, square root of 2 over 2, and square root of 3 over 2, right? Square root of 1, 2, 3. Square root of 1, 2, 3 over 2, and that first one's the same as a half. And then 0 and 1. That's it. Those are the only values on the unit circle. Those are the three we memorized, right? 1, 2, 3 in every quadrant. Those three in every quadrant. Well, then how are we going to do the sine of negative 2/3? It's not one of our memorized spots. So that means we need to use our calculator. That makes sense? So this would be on the calculator part of exam number 3. So let me write that first off. When the value is not, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, 0, 1, or some combo thereof. What do I mean by that? Well, I mean like you could have, for example, like tangent of some angle is square root of 3 because, it was square root of 3 over 2 over a half and these canceled. You know how tangent's a combo. So you can get some kind of combination because tangent sine over cosine, right? So it combines a couple of those and tangent might end up being root 3. Those we use in a circle. But when the value is not those or those, then you must use the calculator. Right? You tracking with me? Do you know how this works? Is this making sense? So you want to think this tomorrow on the exam. You want to have a lot of doing math and science well. Is not just education studies have showed people that are successful in math, science, and foreign language. It's all the same kind of thinking. Organized, categorical thinking. So I'm trying to help you with that. I'm trying to put it in files in your mind right now. So when you take that exam tomorrow and you get these, this is going to be the hardest stuff on the exam, but the hardest stuff all semester. You're going to look at it and go, okay, first off, I see minus 2/3. That's not one of my memorized values, right? It's not the small, medium, large, 0 or 1. Got to use my calculator. Okay, okay, great. So we're going to use our calculator. What are we going to do on our calculator? Well, let me come down here again. Sine x is minus 2/3. What do you do then? We're trying to solve for x. X is over here saying, I want to be alone. Get rid of that sign that's in front of me. How do you get rid of that sign? Do you divide by it? You're supposed to laugh at that option. Say, no, Mr. Heron, it's not multiplication. You've said that 100 times. We've got that now, right? I'm hoping. It's not sine times x, huh? It's not sine times x. It's sine of x. It's plugged into the toaster. Did you have toast this morning? It's plugged into the toaster. So how do you get rid of sine then? If it's not multiplication, so you can't get rid of it by dividing, how do you get rid of it? Sine inverse. We good? That's how you get rid of functions. You don't divide because they're not multiplication. You inverse them. Okay, so I sine inverse, bye-bye. X is alone, so it's sine inverse of minus 2/3. Take out your handy-dandy calculator. They want us to be in radian mode, so make sure you're in radian mode. Go to my mode button here. I'm in degree. Got to go to radian. Okay, and then hit sine inverse of minus 2/3. I'm getting x equals negative point. I don't know how many decimal places they want. 7297. Okay? But that's not the only answer. And herein comes the trick, huh? Getting the second answer is the hard part. So I'm hoping that's fairly straight ahead, that you can do that much. That you realize you got to hit sine inverse because it's a calculator one. This is good so far, but getting the second answer is where the trickery comes in. We good to hear so far? Screen here. So 13 continued. So we have sine x is minus 2/3. So the first answer we have is negative 0.7297. Okay, so we have one answer. Now, there's always a second answer between 0 and 2 pi. There's always a second answer, right? Just like there were for all these other ones. Okay, so how do you know where the second answer is and exactly how to find it? So this is the hard part. You with me? We'll do this again probably when we go over the practice exam. Today we're gonna do the practice exam, right, in the last hour. But it'll be good to do it twice. I want to do it with you right now once, and then because this is the hard part, this fools people a lot. So how do you find where how do I even know there's a second answer? Well, because there's two quadrants. All students take calculus, right? All 6 trig functions are positive. Sine is positive there. All student tangent is positive here. Cosine is positive there, and the other 4 trig functions are negative, right? Okay, so that means there's 2 quadrants where sine is what? What are we looking for? Sine is positive or negative?
Negative.
Negative, right? That's saying sine equals a negative 2/3, negative number. So where is sine negative? Boom and boom, right? Because all 6 trig functions are positive in the first quadrant. Sine and his reciprocal cosecant are positive in the second. The other 4 are negative. So that's not where sine is negative. Third, tangent and his reciprocal cotan are positive. The other 4 are negative. That would include sine. And in the fourth, cosine and his reciprocal secant are positive, and the other 4 are negative. That would also include sine. So sine is negative. That's a sine is negative here, and sine is negative there. Right? Okay. So therefore there should be 2 answers. That's where I'm coming up with the 2 answer things. There should be 1 answer in the fourth quadrant and 1 answer in the third quadrant, right? Because there's 2 places where sine will equal a negative number. If you're saying, give me all the x values, that's what they're saying. Look back at the original question. They're saying, what are the solutions in the interval 0 to 2 pi? 1 rotation. That's 1 rotation. They say, give me all the answers within 1 rotation, where sine will be negative 2/3. So we say, oh, okay, well, there'll be 2 places. There'll be one of them in the third and one of them in the fourth. All right, how do we find those 2? Well, we got one of them right here. Now that one, is that the third quadrant answer? It's kind of weird. It's radians. We don't naturally think radians doesn't even have a pi. It's weird. You're just going to probably need to know is by some other means. See if you do. You've had it, but we've had a lot of facts for 3 weeks, I know. Is that the third quadrant answer, or is that the fourth quadrant answer? It's the fourth. Why? How can we know that? Because I told you, I know I've told you a million things. Again, I know I don't expect you to memorize everything, but that's why I'm here to remind you. Remember the restricted quadrants. Remember when you hit the sine, whenever we do sine inverse, tangent inverse, cosine inverse, remember sine inverse and tangent inverse do those 2 quadrants, and cosine inverse does those 2. That's what your calculator knows. When you hit, we just did, right? We hit the buttons on our calculator. It's going to, for sine inverse, it's always going to give us the right 2 for sine inverse and tangent inverse. It always gives us these right 2 quadrants. Remember that? And cosine inverse gives us the top 2. Nobody gives you quadrant 3 directly with the calculator. You're going to have to get that one yourself by hand. Remember that? Remember those are the restricted quadrants. That'll be important in calculus to keep that fact straight. Those are the restricted quadrants for the inverse trig functions. Remember, because they didn't want 2 answers. This might be confusing, but we're getting 2 answers, right? But they wanted they wanted the initial, just hit the sine inverse button to give you only 1 answer. And so they restricted the quadrants. Remember that? Because they literally wanted only 1 answer. And they knew there was 2 places where where every function was positive and 2 places where it was negative. They didn't want 2 answers when you hit the button. So the sine inverse button, or the tangent inverse button, or the cosine inverse button. They don't want 2 answers coming out of your calculator. So they restricted the quadrants, right? First, everybody uses the first quadrant. Notice they're all in the first quadrant. That's where you get the positive answers. And then they all use one other quadrant other than the first. Sine inverse and tangent inverse use the fourth. Cosine inverse uses the second to give you the negative values. So that's a fourth quadrant answer. That angle is a negative angle somewhere down here. Let's get specific now. That means this angle is something, I don't know exactly where, I don't need to know, but it's negative 0.7297. It's like that. It's from 0 down. It's a negative angle and it's in the fourth quadrant, right? Need to know that in order to be able to get the other one. Where's the other one? It's in the third, right? Exactly where in the third? Well, it's going to be a mirror image in the third, which means it's going to be down, or, well, it's going to be, we'll talk about down or plus in a minute, but it's going to be 0.7297 off the axis, just like the other one is 0.7297 off of the axis. Now is where we get a little bit more into reference angles. Are you guys up for all this at 7 a.m. in the morning? I know I'm laying the big, this is one of the hardest, trickiest things. You with me? You feeling alert? That's called a reference angle. Remember reference angles? It's a little more serious now about reference angles. I've been trying to not get too much into them. I know they're confusing, but I think you've had enough now to where you're ready to deal with it more seriously. A reference angle is with reference to the x-axis, isn't it? That's what we mean. When you say, hey, I referenced, that means you referred to something. So a reference angle refers to something. What does it refer to? The x-axis. Remember how we always said it's off the x? Here's the x-axis, and here's the x-axis. So both those are coming, notice, off the x-axis. Why? Why the x and not the y? I've said that too, but again, I've said a million things. Anybody know? Why do we use the x-axis all the time with the reference angles, not the y? Anybody know? I don't expect all to know, but I was hoping one or two maybe remembered. Because that's where it all started. That's where 0 degrees is. Simple as that. That's where that's all angles come from 0 originally. The x-axis, they could have picked 0 to be straight up in the beginning. And then all of our work would have been to the y-axis. But they picked 0 to be on the positive x-axis. That was by just common agreement, no logic there. They just said, hey, we'll make 0 the x-axis. Once they made that decision, everything comes from the x-axis. All angles are off of the x. They're with reference to the x-axis, right? When I say, hey, I'm looking at a 30-degree angle, we all mean 30 off the x-axis, don't we? That's the definition of what a 30-degree angle is. It's 30 degrees open from the x-axis, not the y, because they picked 0 to be the x, right? All right, probably giving too many details. So, all right, so what? So that means that this, and we're looking for this angle here in the third quadrant. Now, when I say that angle there, you think, well, there it is right there. It's just, Mr. Heron, it's just 0.7297. No, that's not the actual angle. As I just said, if I put an angle in the fourth quadrant, the actual angle starts from 0 and goes all the way there. This little 0.7297 thing I'm writing is just how far it is from the nearest x-axis. That's its reference angle. That's not its actual angle. Its actual angle is how far it is from 0 degrees. That's what we actually need. So we're getting to be too much stuff on that graph there. Let me clean this up a little bit. So let's be super clear on that. So here's the angle that they actually want. They actually want from 0. That's real angles and how you say it. Not just from the nearest x-axis, the 0.7297. All that is how far from there to there, from here to there. That's what the 0.7297 is. That's the same thing as it is over here. It's just negative over there because it's down, right? So with all of that, so you need to know all of that well to be able to answer this. That's why this is a hard question. There's a lot of precursor knowledge you've got to have straight. So we want to know from 0 degrees all the way to this third quadrant answer is how far. And all we know is 7297 from the x-axis, because it's got to be same position in both quadrants, because it's the same sine value, right? The sine is negative 2/3 in both quadrants. So it's going to be the same position, meaning same reference angle, same distance from the x-axis in both quadrants. So it's going to be 7297 off the x-axis in both quadrants. But what is it overall? What is it really? What is it from 0? How are we going to find that out now? Now we're ready. How far from here all the way to there? From here to here is 7297. Yeah, from here to here is pi. Exactly. Pi radians, 180 degrees. Pi radians, right? So then how far all the way to here? Pi plus 7297. Right? Does that make sense? Because halfway is pi, right? To get to here is pi, and then 7297 more. So it's pi plus 7297. So the other answer is pi plus 0.7297. The positive version, not negative 7297, right? That other answer is negative because it's down from the x-axis, but we're not down. We're pi and 7297 more added. So now use the pi button on your calculator, 3.14159, blah, 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 whatever your calculator says. Just use the actual, you don't want to just use 3.14. That's not accurate enough, right? We got to be accurate to 4 decimal places, they said. So you got to use, you guys have a pi button on your calculator, right? You know about that already, right? So pi plus 0.7297. I'm getting the other answer as 3.8713, it rounds to. So the two answers are, the other one is negative 0.7297. Sorry, I'm running out of room there. Let me try that again. So the two answers are negative 0.7297 and positive 3.8713. There they are. So these are really right. They just want it said differently. These are both right. Now let me say it correctly. They're happy with this one. They don't want that one. Why not? Why not? Well, I better read the instructions. What does this say? Does it say negative answers are okay? No. It says between 0 and 2 pi. In other words, no negatives, please. No negatives. Okay, well, what then? Well, these still are the two spots. It's all about how you say them. Those are the two spots. It's just all about putting them in the right language. That's what's hard about this. There's a million ways to say these different angles, and they'll ask for different ways at different times. So we've already got this one. This one's done. He is pi plus 0.7297. He's 3.8713. 8713. Yeah, we're done with him. Now, what about this one? He's negative 0.7297, but they don't want me to say it that way. Okay, well, how do you say it positively? How do you say how far from here to there positively? Good job. Right. All the way to here, 2 pi, subtract 0.7297. That makes sense? Go all the way 2 pi and then back up 0.7297. That's right. So it's going to be 2 pi minus 0.7297. Hit the buttons on your calculator. So use the pi button again. I'm getting 5.5535 or 5535. Yeah. Is that what they got? So there we go. There's one answer. There's the other answer. Okay, so having said all of that, let me clean it up for you. So let me give you a game plan. Using the calculator for inverse trig. How do you use the calculator for inverse trig? Well, it's all about the quadrant you're in. If you're in the first quadrant, that's easy. But if you're in the second quadrant, it's all about reference angles. You come off the near x-axis, call that theta or whatever. In fact, I'm going to call it R for reference. How about that? R for reference. Reference means coming off the x-axis. How would you find the actual angle? I'm going to give you a formula, a game plan for every quadrant that you should put on your 3x5 card. Probably write it on the sideboard as well, so Mr. Garside can erase it. All right, so here we go. So in the second quadrant, it is pi minus r. How so? Because to get there, you go all the way to here, which is pi, and then back up r. So if you're trying to find an angle in the second quadrant, it's pi minus r. If you're trying to find an angle in the third quadrant, again, this is r. R is the reference angle off the x-axis with reference to the x-axis. It's going to be what? Can anybody tell me what it's going to be? Pi plus r. Pi plus r, because you go all the way to here, pi, and then go r further instead of backing up r. Does that make sense? And if you're in the fourth quadrant, if you're all the way to here, and again, this is your r, it's going to be all the way to there, it's 2 pi minus r. So there's your formula for the angle. In the first quadrant, it's just r. Right? First quadrant, it just is what it is. You don't need to mess around. But there's the formula for how you will turn a reference angle into an actual angle in any of the other three quadrants. Right? So here I'll put a box around these three formulas. So in the second quadrant, it's pi minus r. Third quadrant, it's pi plus r. Fourth quadrant, it's going to be 2 pi minus r, where r is the reference angle, the angle to the nearest x-axis. So all you guys, so anyway, so do it. So let me do this problem real quick and easy for you now. Now that we have those formulas, and I'll put them on the sideboard in a minute. Here's what you should do. I gave you the big long story, which I don't know, it can be helpful, but also can be overwhelming. So I want to give you the details and all the reasons why. But let's get down to nitty gritty. How are you going to do this on the test tomorrow? You're going to see this question. You're going to take your calculator and hit the buttons. You're going to go sine inverse and negative 2/3 immediately. And when you do that, you'll get negative 0.7297. Wasn't that what it was? Right? And then you'll go, okay, now what is that answer? You won't worry about the negative. Just right away say reference angle is 0.7297. I hope that's not confusing because you think, well, no, but it's negative, Mr. Train. Yeah, it's negative. But that just means that's how far down it is from the x-axis. I don't care. I just want to know how far from the x-axis. Call it positive, call it negative, whatever. That's the distance to the x-axis, right? So, and then I go, okay, now what are my, then I'll go, what are my two quadrants I'm looking for? These two, because that's where sine is negative, right? The all students take calculus. Oh, okay, sine is negative in these two quadrants. So I need a third and fourth quadrant answer. How do you get answers in the third? You go back to the formula. Oh, pi plus r. So you go pi plus your reference angle, 7297. How do you get a fourth quadrant answer? 2 pi minus r. You'll go 2 pi minus your reference angle, 0.7297. Boom, boom, done. Make sense? So you just hit the buttons. Use the reference angle as, you don't worry about the negative, just take the reference angle, and then find the two quadrants where you're going to have answers, and just use the formulas to get the answers in those two quadrants. Like you can do that? That'll work for you? Why don't we try one of these? All right, let's try this one, number 14, I mean. 16 sine squared x minus 1 equals 0. We're going to use our calculator. Let's solve that one. What's the first step on this thing? Step 1, Get that sine cosine thing alone, so add 1. Yeah, it's going to want 4 answers for another reason. What do we do now? Trying to get the sine alone. What's next? 5 by the 16. Right. So, we're good to here. Now, here's the step that will lead us to know there's going to be 4 answers. How do we turn sine squared into regular sine? Square root, right? That's what cancels out the square. And when you put a roof on the house, remember my dorky saying? I hope it is just dorky enough that you can't forget it. When you put a new roof on the house, you got to go up. This isn't working so well for you guys. Right? You got to go up and down the ladder. It's really dumb, right? If you're going to put a new roof on your house, you're going to have to go up and down the ladder. Remember my dorky saying to help you remember? When you put a roof on the house, a root on both sides, you can't just put a roof. Not just that. You must go plus or minus. Up and down. That's my up and down the ladder. Right? So I'm trying to help you remember that. So yeah, that's where it all comes from. Because we get, that's going to be 1/4, huh? Square root of 1, square root of 16. We get plus or minus 1/4, don't we? Yeah. So we're going to get 2 answers. So you could separate. Let me just separate it right now. I'll just separate it right now. You're going to get 2 answers that come from the sine positive 1/4. And 2 answers that come from the negative. And you already know it, right? The negative, we just did a negative problem, negative 2/3. You're going to get answers in the third and fourth quadrants. And for the first one, you're going to get answers in the first and second, aren't you? Because of all students take calculus, right? You with me? All students take calculus. All students take calculus. So sine is positive in the first and second quadrant, sine positive. Sine negative in the third and fourth, as we just saw in the last problem we did. Right? So where's the sine positive fourth? You're going to get a first and a second quadrant answer. Where's the sine negative fourth? You're going to get a third and a fourth quadrant answer. Right? Go to it. Using those steps. Can you get those? So you just hit the buttons on your calculator, right? Sine inverse of 1/4. I'm going to do it to make sure you're in radian mode, right? I'm getting 0.2527 it rounds. 268, so yeah, 2527. Good, y'all getting that? So that's the reference. That's the R equals, isn't it? Okay, so we have excuse me, first and second quadrant answers on this one. They want everything 0 to 2 pi, I'm assuming. Yeah, 0 to 2 pi. So first and second. So in the first quadrant, it's just that straight. I hope that made sense. It's just the reference angle straight. The first answer, the reference angle, so in this quadrant, it is just 0.2527. In this quadrant, it's pi minus 0.2527, right? Because that's the formula for second quadrant. So write down the 2 answers. 2527, comma, whatever your calculator. Use the pi button on your calculator. I just use pi minus, and then I use the answer button. That way I don't have to type stuff in. It's super quick. It's super accurate. Do you know what I'm saying on the calculator? I have an answer button. Most of you do too. So I just hit the pi button minus answer, last answer. I don't have to type it in, write it down, all that. It's more accurate and it's more fast. So I'm getting 2.8889. So there's those 2 answers. Let's do the other 2. Is that good so far? Question so far. Now what about the other 2? Well, that's going to be third and fourth quadrant because that's where sine is negative. How do we get third? Pi plus the reference. Fourth is 2 pi minus the reference. What's the reference? It's the 2527. 2527 and 2 pi minus 0.2527. Hit the buttons on your calculator. I'm getting 3.3943. And then 2 times pi. 2 pi minus 0.2527. I'm getting 6.0305. There's my 4 answers. How we doing?